Welcome everyone. In the previous video about polynomial division, we covered how to divide polynomials using long division. In this video, we're going to see how we can perform this polynomial division using a different technique. That's by equating coefficients. Okay, so we already know that two polynomials, px and qx, are equal if their corresponding coefficients are the same. So that's the concept we're going to use to divide the polynomials here. If polynomial px is divided by dx, we can write the whole thing like this: px equals dx, dx is the divisor, times qx, the quotient, plus rx. So we can do the same example as we did in the long division. 4x cubed minus x minus 2 divided by 2x minus 1. So this one is px and 2x minus 1 is the divisor. We're going to find qx and rx. So let's substitute these polynomials into this equation, and this becomes 4x cubed minus x minus 2 equals dx, which is 2x minus 1, times qx plus rx. I'm just going to write it as just r. And what is the qx we're going to expect? Okay, this is a cubic polynomial and we're dividing by a linear polynomial. The answer should be, the qx should be a quadratic polynomial, the one with degree 2. The general form of qx, the quadratic polynomial, is ax squared plus bx plus c. So if we can find I, b and c, then we can write qx squared easily. That's the quotient we're going to find. Okay, so let's rewrite this one as this equals 4x cubed minus x minus 2 equals 2x minus 1 times ax squared plus bx plus c plus r. So now if we can find the coefficient a, b, c and r, we can get the quotient as well as the remainder. Okay, let's do that. And before we are able to equate the coefficients on both sides, now we have a polynomial px in here and then another polynomial in here. So these two polynomials are equal only if their corresponding coefficients are same. We are not in a situation to equate the coefficients yet. We need to do a little bit of a expansion and then simplification, etc. So let's do that in here. So first we need to expand this bracket. So multiply 2x with all the terms in the second bracket and then minus 1 with all the terms in the second bracket. Let's do the 2x one first. 2x times ax squared is 2ax cubed and 2x times bx is 2bx squared, and then 2x times c is 2cx plus minus 1 times ax squared. So I'm just going to write down in the next line, it's minus ax squared and minus 1 times bx, and that's minus bx, and minus 1 times c is minus c, and then there's a plus r. Okay. Now we can combine all the like terms together. So 2ax cubed, there's only one term having power 3, so that's 2ax cubed. And then these two terms can be combined together because they both have the same variable, x squared, and minus plus 2b minus a x squared. And these two terms can be combined, so that's plus 2c minus b x, and then the last constant term is minus c plus r. Okay, now we can compare the terms on both sides. So now we can compare the coefficients on both sides. This side is 4x cubed minus x minus 2 and this side is this one, and we can compare the coefficients of x cubed first. So that gives us 2a equals 4, or a equals 4 on 2, which is 2. Okay, we got a. Now we can take the coefficient of x squared on both sides. So 2b minus a on the right, on this side, and then there's no coefficient, there's no term with x square in here, so which means the coefficient is 0. A is 2, and then this becomes 2b minus 2 equals 0, or b equals 2 on 2, which is 1. So we got a and b. Now let's compare the coefficient of x on both sides. So 2c minus b equals minus 1, and b is 1, so it's a 2c minus 1 equals minus 1, or 2c equals minus 1 plus 1, which is 0. That gives c as 0. Finally, we need to get r as well. So let's compare the constants on both sides. Minus c plus r is the one on that side, and this side it's minus 2, and c is 0, so that gives us r equals 2. So we got the coefficients a 2 and b 1 and z 0 and then r 2. So now the answer is then qx equals ax square plus bx plus c. That's what we selected q for, and a is 2, so it's a 2x square, and b is 1, so it's a x, plus c is 0, and then the remainder rx equals minus 2. No, it's r equals minus 2, isn't it? R equals minus 2. Okay. This polynomial division, whatever method you choose, is an important one because you can use this polynomial division to factorize the polynomials, which in turn is really important to find the x-intercepts of the higher degree polynomials, such as cubic polynomials, quartic polynomials, or polynomials of higher degree than that. Okay, let's stop here.